gets.
Okay. Good afternoon, everyone. Today we'll be presenting our progress report. Uh, um, sorry, I'm trying to okay. Good afternoon, everyone. Today we'll be presenting our progress report. Next, um, our group um, our group has done two previous progress reports previously. There's the first report and the second report. Feel free to click on these links if need be. Um, Continue. Today's report will consist of first mainly the introduction, and the second is the landing gear design. The third will be the stability and control analysis, and the fourth will be performance analysis, and lastly will be the cost analysis. Next. No. As an introduction, these are the following updates from the previous report. The previous report didn't have an in-depth description of the dimensions of the airplane. For this report, we have gathered a more in-depth report of the dimensions of the airplane. Um, Next, this is a more complete representation of the dimensions that was mentioned previously. Feel free to pause the video if you would like to um, see it in more detail. Um, Next, next will be the landing gear design presented by Gregorius Gintings.
Okay, thanks, Raihan. Okay, now we will talk about the landing gear design. So our landing gear is using the tricycle configuration and fixed landing gear. Okay, next. Okay, for the kickback angle of our aircraft, we will have we will have 16.22 degrees, and for the turn angle, we will have 7.92 degrees. Okay, next. Okay, and for the wheel diameter, the diameter diameter, and the tire diameter is shown in the table, which is for the main landing gear and nose landing gear. You can read it in the table. Okay, next. Okay, and for the stability and control analysis, we are calculating the Cm alpha and Cn beta and static margin for the typical value I calculated. And we also create a graph for the Cm versus angle of attack. As you can see. Okay, next. Okay, and for the performance analysis, we are creating the graph of CL versus CD and L per day versus CL for three flight conditions, which are cruise, takeoff, and landing. Okay, next.
Okay. And for the next one is about the performance analysis. The first one is for the engine performance, referring to the uh, propeller chart. We can know the maximum efficiency of the propeller at some pitch angle of the propeller, and then using the reference of our engine power, which is in the maximum of 596 kilowatt, the engine power will decrease as the altitude increasing, and the fuel consumption rate will increase as the altitude increasing. And then these are some calculation on the takeoff performance. The takeoff distance will be for 493 meters. And then the next one is calculation for the landing performance. The landing distance will be 477 meters. And then the climb performance, the maximum rate of climb at sea level will be around 1800 feet per minute. And then the surface ceiling is the altitude where the maximum rate of climb is less than half meter per second. The maximum surface ceiling is around 10,000 kilometer, 10,000 meter from the ground. And then the next one is the cruise range. We calculate configurations for the cruise range. The first one is with maximum pilot, and then the second one with 400 kilogram of pilot. For the maximum pilot, the maximum range will be around 800 kilometer, and then for the 400 kilogram of pilot, the range will be 2600 kilometer. And then this is our flight envelope for our aircraft, describing the stall speed, the maximum cabin altitude, and then the diving speed. And then this is the summary of our performance evaluation. So all of our performance has already complied the DRO. And then next one, the cost analysis will be presented by Bayu.
Okay, so for the cost analysis, we estimate the cost based on the sizing of the aircraft and also the performance of the aircraft itself. We base our calculation based on a few literatures, but ultimately for our aircraft, the amount, the price is around 2.4 million, which is which fulfills the DRO. And in order for us to reach that price, we need to produce the aircraft for around 300 aircraft, but to achieve a price of 2.1 million, we need to produce the aircraft for around 400 units. And compared to other aircraft, our price is definitely competitive, considering the fact that it's also much more modern and it's unmanned too. Okay, I think it's done. So
Okay,
thank you.
thank you for today's presentation.